So suppose we have a problem like this, where we have the bases are the same and the unknowns are in the exponent. So how do we solve this? Now, again, the bases are the same here, so we can just set the exponents equal. So we could just say x equal 3x plus 6, like that. Then bring the 3x's to the left, divide by -2, and then x is equal to -3 like this. Now suppose we have the case in which the bases are not the same. In some of those cases, we can in fact still make them the same. So let's say if we have a problem like this. So here, 9 is not equal to 27. So we can't just do this directly. So we're going to have to do something here. So, but remember that 3 squared is 9 and 3 cubed is 27. So what we can do, we can say that 3 squared 2x minus 1 is equal to 3 cubed x plus 4 like this. So all I did was replace 9 by 3 squared, 27 by 3 cubed. Now, let's go ahead and simplify the exponents. Remember, if you have a power of an exponent to another exponential power, you multiply the exponents, don't you? So this is going to be 2 times 2x minus 1. That's going to be 4x minus 2. Then over on the right-hand side, we're going to have 3 times x plus 4, like this. Again, we have the bases equal, so we can set the exponents equal once we have the bases equal. So we can make this 4x minus 2 equal 3x plus 12, like this. And let's bring the 3x over here, combine with this, that's just going to be x. Bring the 2 over here, that's going to be 14. So that's the answer to this problem up above here. Let's do a couple more. Let's do this example here. This is 25 to the 3x plus 1 equals 5 to the 2x minus 7, like this. Once again, the bases aren't the same, but here we have a 5. We can turn this into 5 squared. So this will be 5 squared. That replaced our 25. Right-hand side, we have this. Again, if we multiply the exponents, 2 times this is 6x plus 2, 5 2x minus 7, like this. Again, since the bases are the same, the exponents are going to be equal. And let's combine the x's and bring this over to the right. Then if we divide by 4, we get x equal to minus 9/4. Again, we always have to make the exponents equal. And so let's take another one here. Let's take a look at this problem. 9x times 3 to the 7x equals 1 divided by 9 to the 2x minus 6, like this. Now we're going to need to get these, the left-hand side and the right-hand side equal. Now, there's probably a lot of ways to do this. I'm just going to pick one particular way. I'm going to turn everything on the left into threes. So like on the left here, we can make our 9 into 3 squared. And then, of course, we have 3, 7x over here. And on the right-hand side, again, a lot of ways you can do this. I'm going to, again, change the denominator into threes again. So again, this is 1. So this is 3 squared. 2x minus 6 like this. And now on the left here, I'm gonna put all the steps in. You don't have to put all these steps in. This becomes 2x, 3, 7x. Over here, I'm gonna multiply this out. 1, 3, 4x minus 12 like this. Now, the final thing we need to do, we need to get the left-hand side to have threes, just 1 3, and the right-hand side to have 1 3s, but it has to be in the numerator. So I'm going to combine these. Remember, if the bases are the same and we're multiplying, we add the exponents. So the left-hand side is going to be 7x plus 2x. That's going to give us 9x. And then we're going to bring the right-hand side from the numerator, from the denominator to the numerator. Remember, we have to change the sign of the exponent when we do that. So if we bring that up, this is going to change to minus 4x plus 12, because we had to change the sign of the exponent when we did that. Now, finally, we're at the point we have a 3 as a base on the left, 3 as a base on the right. Now we can set the exponents equal. And let's bring this over to the left-hand side. That's going to give us 13x equals 12. Divide by 13. X is going to be equal to 12, 13, like that. Now, finally, let's do a more complicated one. Let's take a look at this problem. This is 8 to the x squared plus 1 Divide by 4 to the x squared minus 2x, 2 to the minus fifth, 16 to the minus 3x plus 1, like this. And now, again, we have all kind of numbers here. So we want to try to find a common base. Now, here we could make them all into twos, can't we? Because 8 is 2 cubed, 4 is 2 squared, 16 is 2 to the fourth. So let's go ahead and do that. Again, we said that that's 2 cubed. This is 2 squared. And it's already 2 to the minus fifth here. And then this is going to be 2, what do we say? 2 to the fourth, huh? Like this. Again, let's multiply through again. This is 2, 3x squared plus 3. And the denominator, 2x squared minus 4x. Minus 12x plus 4, like this. Again, let's bring this up. And I'm going to put all the steps in. Again, you could take the shortcut on a lot of these, but I want to be sure everyone sees all the steps and understands them. Like this. So notice what I did. I changed the sign of this exponent to minus 2x plus 4x. Change the sign of this exponent to 12x minus 4. Brought them up. Add the exponents. Again, this is going to be x squared plus 4x plus 3. This is going to be 12x minus 9, like this. So now we have the base of the same. Now we can set the exponents equal. And so let's continue here. So again, we're going to set these exponents equal. So it's going to be x squared plus 4x plus 3 equal 12x minus 9, like this. The x squared, bring this over here. That's going to end up giving us a negative 8x. Bring this over. Plus 12 is 0. So now we can solve this. We can either use a quadratic formula or we can try to factor. If we try to factor, two numbers that multiply give us 12, but add to give us minus 8 is going to be minus 2 and minus 6. Then, of course, what's going to make this 0 is if this is 0 or this is 0. So the answers are x equal 2 and x equals 6.